In this video, I'll give an introduction to servo motors and how to interface a servo motor with a microcontroller. Components of a DC servo motor. Components of a DC servo motor. A DC servo motor contains a normal simple DC motor, gear mechanism. This is the gear mechanism, potentiometer or encoder to provide feedback of the position, and control circuit. So we have DC motor which is connected to gear assembly and a potentiometer. The potentiometer provides the feedback of position. Now this feedback is compared with the input reference signal and the output signal changes based on the difference between the input signal and the actual position. So in this way we achieve the desired angle of the motor. Now some of the motors are contains encoder instead of potentiometer. Okay. Now how to interface servo motor with the microcontroller? So for that you need to understand the number of pins of the servo motor. This pin is connected to VCC supply, VCC supply that is required to drive the motor. So this is connected as per the motor rating, and this pin is connected to the ground, and the last one is connected to the control signal, which is a PWM signal. So we have to provide a PWM signal from the microcontroller. So in the PWM signal we vary the pulse width. So based on the pulse width, the angle of the servo motor also varies. So we vary this t on time of the waveform, square waveform. Okay. To interface with microcontroller, we need to connect the control pin of the servo motor to the PWM pin of the microcontroller. So in the 8MEGA16 microcontroller, the OCO0 is the PWM pin which is linked with the timer 0. So if you are using timer 0 to generate PWM, then it is connected to the OCO0 pin. Now in this diagram, we have used OCO0 pin which is linked with the timer 0. But since the PWM frequency which is 50 Hz required to drive this motor cannot be provided by timer 0, so we generally use OC1A pin of 8MEGA16. So practically it is connected to the OC1A pin of the microcontroller. Yep. So for other microcontroller development boards, you can find a proper or a appropriate or the PWM pin, and then you can connect the control pin of the motor to the PWM pin of the microcontroller. Frequency of the PWM. So we have to generate 50 Hz frequency of the PWM. So it means this T is equal to 1 upon 50 is equal to 20 millisecond. So we have to generate a square waveform or PWM waveform of 20 millisecond time period. So the time period is equal to 20 millisecond. The servo angle varies from 0 to 180 degree. The servo angle generally varies from 0 to 180 degree, but it depends on the motor. So in this example, we are considering a servo motor that varies in angle from 0 to 180 degree. Duty cycle varies 5 to 10% for the range 0 to 180 degree. So the angle 0 to 180 degree is mapped to 5 to 10%. So it means we have to vary this duty cycle, and the duty cycle is equal to T on divided by capital T into 100. This is the T on time and this is the time period. So the duty cycle is equal to T on divided by capital T into 100. So this T on varies 5 to 10%. So it means 5 to 10% of 20 millisecond. So 5% of 20 millisecond is equal to 1 millisecond, and 10% of 20 millisecond is equal to 2 millisecond. So we have to vary the T on time from 1 to 2 millisecond. So T on varies within this range 1 millisecond to 2 milliseconds. So this 1 to 2 millisecond is mapped to 0 to 180 degree. Now let's understand the basic calculations. So FPWM is equal to 50 Hz, TPWM is equal to 20 millisecond, duty cycle range 5 to 10%. So therefore T on is equal to 1 millisecond to 2 millisecond. This is the relationship between the duty cycle and angle of the servo motor. So as we discussed, the duty cycle varies from 5% to 10%, and corresponding angle varies from 0 to 180 degree. So this is corresponding to 180 degree, and this point is corresponding to 0 degree. So this mark is 180 degree. Now from this plot we can find out a relation, because angle is a function of duty cycle. So based on that we can find out a relation between angle and duty cycle. So we can write an equation of the line. So angle is equal to 36 into duty cycle minus 180 degree. We can find out the duty cycle for a given angle. So duty cycle is equal to angle plus 180 by 36, and the pulse width is equal to 20 millisecond into duty cycle divided by 100. Let's take an example. Determine the pulse width T on for 92 degree servo angle. So for example, let's say we want to rotate the servo angle to 90 degree, 92 degree. So for that we have to find out the T on time. Okay. Now first we will find out the duty cycle corresponding to this 90 degree angle. So duty cycle is equal to, the duty cycle will be 92 plus 180 by 36. Okay. This will be the duty cycle, and then we have to find out the T on time. So T on time will be the 0 we can find out T1 can be find out by multiplying this by 0.20. Okay, so this will be the pulse width. So we have to generate a pulse width of, we have to generate a PWM signal of pulse width of 1.51 millisecond, and the capital T or the time period of the PWM will be 20 millisecond. So this 20 millisecond will be constant for all the angles, and then we have to change this T on time. So this T on will depend on the required angle. That can be find out from these equations. Now how to generate the required PWM using Atmega 16? So for that we have to use timer 1. So we can not generate 50 Hz PWM using timer 0.